third grade. All right, our second lesson for this week. We are doing lesson 6 in module 4. We're starting on page 103, and it's multiplying with nines. So the last video was multiplying by 8s. Now we are moving on to multiplying with nines. So when you're done, you should be able to apply the distributive property with multiplication and addition or subtraction, and you should be able to use patterns and strategies to multiply with 9. So Toby is measuring the length of Lee's shadow using footsteps. Lee's shadow is 6 footsteps long. Toby knows that his footstep is 9 inches long. What is the length of Lee's shadow in inches? So we're going to show more than one way to find the length of Lee's shadow. So we know that he needs 6 footsteps to measure his friend's shadow. And each of Toby's footsteps is 9 inches long. So this would be 6 times 9, right, would be our multiplication equation. So let's figure out a couple of ways that we could find the length of Lee's shadow. So we're going to show more than one way. One way we can always do is to do an array. So we know that we need 6 footsteps, and each footstep is 9 inches. So I need 6 rows, and each row is going to have 9 in it. 3, 4, 5, 6, 7, 8, 9. Then I'll fill in the rest of my array. So go ahead and make your own array with 6 rows of 9. So each row, you need 6 rows, and in each row there should be 9 squares in each row. So you've got your 6 rows, and there are 9 inches in each row. So how could we multiply this? Well, let's see. Let's break up our 6. Well, I know I could break up my 6 in half, right? And then that would give me both. This problem up here would be 3 by 9. So this would be 3 times 9. And this section down here would be the same thing, right? 3 times 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So 3 times 9 equals 27. And then I will double it. So 27 plus 27. 7 plus 7 is 14. Regroup my 1. 2 plus 2 is 4, plus 1 is 5. So 6 times 9 is 54. So Lee's shadow would be 54 inches. We're just going to show one way because we've got lots of practice on the next couple of pages. So instead of more than one way, we're just going to show our one way because it kind of took up a lot of space. Okay. So now we've got some yogurt. Each 8-ounce container of yogurt has 9 grams of protein. A gram is a metric unit used to measure mass. Tanika is finding the total grams of protein for different numbers of containers. Tanika knows that the products, when multiplying with 0, 1, 2, 3, 4, 5, 6, and 7, how can Tanika find the products 8 times 9, 9 times 9, and 10 times 9? Well, let's see if we can see a pattern in our table. So we're going to first complete the products, and we're going to see if we can notice any kind of a pattern. So 1 times 9, well, this is our identity property. Anything times 1 is going to be itself. If I have one group of 9, I have 9 of them. 2 groups of 9. 2 times 9 is 18. Right? If we count 2, 4, 6, 8, 10, 12, 14, 16, 18. 3 groups of 9. 3 times 9. 3, 6, 9, 12, 15, 18, 21, 24, 27. 4 times 9. 4 groups of 9. 4, 8, 12, 16, 20, 24, 28, 32, 36. 5 times 9, or 5 groups of 9. 5, 10, 15, 20, 25, 30, 35, 40, 45. 6 times 9, 6 groups of 9. 6, 12, 18, 24, 30, 36, 42, 49, no, 48, sorry, 48, 54. I was getting ahead of myself. I was thinking of my sevens. 7 times 9. 7, 14, 21, 28, 35, 42, 49, 56, 63. 8 times 9. 8, 16, 24, 32, 40, 48. 8 times 7 is 56. 8 times 8 is 64. And 8 times 9 is 72. 9 times 9. 9, 18, 27, 36, 45, 54, 63, 72, 81. And then 10 times 9. 10, 20, 30, 40, 50, 60, 70, 80, 90. Phew! That was a lot of counting, wasn't it? So do you see, so what was the method we used to find the products of 8 times 9, 9 times 9, and 10 times 9? We basically just counted, right? We counted by 8s, 9s, and 10s. That's how we found it. But let's look at what we're noticing about the tens digit in the product. The tens digit is right here. Can you notice any pattern? I can see one pattern. Look at the tens digit. There's nothing here, so it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Look at, as you multiply, it gets bigger by 1, right? And also, the tens digit is 1 less than the number you're multiplying by. So if you're multiplying 3 times 9, your tens digit will be a 2. If you're multiplying 5 times 9, your tens digit will be a 4 because it's 1 less than 5. 7 times 9, look, your tens digit is a 6. It's 1 less than 7. That's another pattern I'm noticing as well. So there's a couple different patterns that we notice about the tens digit. So it is 1 less than the number multiplied by 9. And also, it's increasing, right? It's just going up by 1 as you get bigger. You go from 1 to 10. And then another thing it wants us to notice is the sum of the digits in the product. So let's see. What that means is when I add the two digits, what do I get? So when I add 9 plus 0, I get 9. When I add 8 plus 1, I get 9. 7 plus 2, I get 9. 6 plus 3, another 9. 5 plus 4 is 9. 4 plus 5 is 9. 3 plus 6 is 9. 2 plus 7 is 9. 1 plus 8 is 9. 0 plus 9 is 9. when I add these two digits up, it equals 9. Oh my goodness. So the sum of the digits is 9. Isn't that crazy? That is an interesting pattern. So that could help you, right? If you think it's one answer, you add up your digits. If you don't get 9, then you know that that can't be the correct answer when you're multiplying by 9. So cool. All right. Well, let's step it on out now. We're going to use the distributive property. So, how many grams of protein are in 7 ounces of pumpkin seeds? So we can see this chart here. It talks about different kinds of foods. So we have almonds, and there are 6 grams of protein. Cheese, 1 ounce of cheese, there are 7 grams of protein. 1 ounce of pumpkin seeds, there's 9 grams of protein. And 1 ounce of squash seeds, there are 9 grams of protein. So it wants to know how many grams of protein are in 7 ounces of pumpkin seeds. So for every 1 ounce of pumpkin seeds, there are 9 grams of protein. So if I want 7 ounces of pumpkin seeds, I need to multiply it by 9 to figure out how many total ounces or how many total grams of protein are in 7 ounces of pumpkin seeds. So we're going to break apart our factor of 9, and so we're going to think of 2 add-ins. So if I do 7 times 9, that's the problem I'm doing, right? And I want to break apart my 9. If I break it apart and I have a 5, what would be added to my 5 to equal 9? 5 plus what equals 9? 5 plus 4 equals 9. So now I'm going to multiply each of these on the inside by my 7 on the outside. So my 7 times my 5, we can see is down here. And I do my 7 times my 4, which is here. So 7 times 5, 5, 10, 15, 20, 25, 30, 35. And my 7 times my 4. 4, 8, 12, 16, 20, 24, 28. And then I'm going to add these together. So 35 plus 28. 5 plus 8 is 13. 3 plus 2 is 5, plus 1 is 6. So 63 is my answer. So there are 63 grams of protein in 7 ounces of pumpkin seeds. So we're going to do the same thing. We're still finding 7 times 9, but this time we're going to use the distributive property with multiplication and subtraction. This strategy is not my favorite strategy. So I'm going to show it to you, but this is one I don't use very often with my 4th graders because it's not one that I'm a fan of, but I will show it to you in case it's one that you enjoy. Okay? So we're going to represent the factor of 9 using subtraction. So I know that the number 9 is 10 minus 1. If I want to get the answer 9, I could subtract 10 minus 1, and that would equal 9, right? So then I need to multiply each piece, but this time, instead of adding them together like I would do up here with the distributive property with multiplication and division, this time I'm going to do multiplication and subtraction. So when I do 7 times 10, I get 70. And then I'm also going to do 7 times 1, which is 7. So then if I subtract 70 minus 7, to do some regrouping, 10 minus 7 is 3. I bring down my 6, so it's 63. So notice it's the same answer, right? We get the same answer whether you break it apart, multiply and add, or break it apart, subtract, or multiply and then subtract. So there are 63 grams of protein in 7 ounces of pumpkin seeds. All right, so we're going to now check for some understanding. So we're going to use this table above. So we're going to use the table way up here, and we're going to use that to help us answer this problem. How many grams of protein are in 9 ounces of squash seeds? So squash seeds, for every 1 ounce of squash seeds, there are 9 grams of protein. And I want 9 ounces of squash seeds. So this is 9 times 9. Now I could look at my chart right over here, right? I've already found 9 times 9. I know that if I'm doing 9 times 9, my tens place needs to be 1 less, which is 8. And then I need to be able to add the 2 digits together to equal 9. Well, I know that 8 plus 1 equals 9. So there are 81 grams of protein in 9 ounces of squash seeds. All right, and now we're on the on your own section, and I forgot to say that on the last video, but when we get to this part, remember you can pause your video and do this independently and then come back and check your answers, or you could stay right with me and do it together with me. Okay? So Darla has 8 pieces of yarn. Each piece is 9 inches long. How many inches of yarn does she have? Explain how you can find the answer using the distributive property with subtraction. So they want us to use that distributive property with subtraction. So we'll try it again. We'll do our best. So she has 8 pieces of yarn. Each piece is 9 inches long. So I know for every piece of yarn, they are each 9 inches. So I need to multiply 8 times 9. Now it wants us to do the subtraction model. So I'm going to do 8 times, and remember it's 10 minus 1, because 10 minus 1 is the same as 9. 10 minus 1 equals 9. And now I have to multiply each piece by 8. So 8 times 10, and 8 times 1, but I'm subtracting this time. 8 times 10 equals 80, and we're subtracting it by 8 times 1, which is 8. 80 minus 8, if I regroup this, my 8 becomes a 7, my 0 is now a 10. 10 minus 8 is 2, and I bring down my 7, so 72. So 8 times 9 is 72 inches. And that's our explanation by solving it like that. Okay. We're going to fill in the unknown number. So this, we can see it wants us to do the subtraction, right? The distributive property with subtraction. So 4 times 9, we're going to have our 4 on the outside, and inside the parentheses, what minus 1 equals 9? Remember, 10 minus 1 equals 9. 9 times 6, we're going to do the distributive property with addition for this one. So I'm going to multiply by 6. So my 6, so I'm breaking apart my 9. So 4 plus what equals 9? 4 plus 5 equals 9. All right, so we're going to find the product. 9 times 1, the identity property. If I have one group of 9, I only have 9 of them, right? 4 times 9. So remember, I can take 1 less than 4 for my tens place, which is a 3. And then what plus 3 will equal 9? 6. So 4 times 9 is 36. 9 times 7. What is 1 less than 7? 6. That goes in my tens place. And then 6 plus what equals 9? 6 plus 3. So 63. Remember, we find our tens place first, and then we can figure out what the ones place is. So 9 times 3. What is 1 less than 3? 2. 2 plus what equals 9? 7. So 3 times 9 equals 27. 9 times 9. What is 1 less than 9? 8. 8 plus what equals 9? 8 plus 1. 9 times 9 is 81. 10 times 9, this one, you just 10, 20, 30, 40, 50, 60, 70, 80, 90. This one's easy because it's 9 times 1, and then you put your 0 at the end. All right, 9 times 8, what is 1 less than 8? 7. 7 plus 1 equals 9. 2. 6 times 9, what is 1 less than 6? 5. 5 plus what equals 9? 4, so 54. 6 times 9 is 54. And then 9 times 5, we could count by 5s, or we could do 1 less than 5, which is 4. 4 plus what equals 9? 4 plus 5. So 9 times 5 is 45. So there are some neat tricks. There are some neat strategies to use with your 9s. Now this only works with your 9s. It's not going to work with any other number you're multiplying by. But it's nice to have a strategy like that that's kind of quick in your head to figure out these 9s until you have them all memorized. All right, I hope you all have a great rest of your day, and I have one more video for you for this week. So when you're ready to do that one, it will be on there. All right, have a great day. Bye, guys.